Configuring advanced DNS settings. DNS is a very essential service that we require on a network because most critical network services depend on DNS. Even Active Directory domain services depend on DNS, and many other services actually depend on DNS. DNS is actually like the blueprint of your network. As DNS, we have the IP address and name of all the computers on your network in its record, in its resource record. So in this chapter, we're going to look at configuring advanced DNS settings. We're going to look at managing DNS services. We're going to look at optimizing DNS name resolution. We're going to look at options for implement DNS security. We're going to look at how DNSSEC works. Our new DNSSEC features for Windows Server 2012. Then we have a lab on configuring DNS security or DNSSEC. Managing DNS service. What are steps we can use to manage DNS services? One of the ways is you can delegate DNS administration. Now, by default, the domain admin has full permission to manage all aspects of DNS on its domain. Enterprise domain admin can manage the DNS information on all the domains in the forest. Now, sometimes you want some people to manage DNS, but you don't want to give them domain admin or enterprise admin privilege. What you will do is put those users in the DNS admin group. DNS admin group is a domain local group by default. Okay, it's a domain local security group, and by default, it has no members in it. So you put those users in that group so they can manage DNS. You can also delegate DNS administration to these groups as long as you to these users or groups as long as you put them DNS admin group. One of the things you also want to do is remove stale record in DNS. Remove stale record in DNS by using aging and scavenging. Why do I need to configure aging and scavenging? It's actually not configured by default. Here's the reason why. You have someone that brings their computer to the office, connected to the network. After they get an IP address from DNS, then they register their info because you're using dynamic DNS in DNS. Then after that, the machine was shut down, machine probably crashed or some reason. The information was never updated. If the information was never updated or properly removed from DNS, that information will be in DNS. And through name resolution, people can get invalid records from that. Your DNS records, replication can be bloated. So what you want to do, configure aging and scavenging that such records are removed by interval. DNS server properties. DNS server property, you can enable DNS debug login. DNS debug login, don't enable it unless you are troubleshooting DNS, because DNS debug login can actually slow down your system. Okay. DNS debug login, we have information such as direction of packets, contents of packet, the transport protocol being used, type of request. Where do I go to access DNS login? I right click, I go into my DNS console. I right click my DNS server, I click on properties, then I click on the tab that says debug login. Backing up methods for your DNS. If you're using Active Directory integrated DNS zones, you can back up your DNS through system state backup using DNS command or using Windows PowerShell. If you are using non-integrated Active Directory, non-integrated Active Directory integrated zone, you can actually back it up by copying the files or just regular backup. Optimizing your DNS name resolution. Now, there's some features that we have in DNS. One of them is forwarding. If your DNS server get a request for a query that doesn't have the information, you can actually configure it to forward it to another DNS server locally or to other specific DNS servers. So if DNS server get a name to resolve www.microsoft.com, looking at it, see Microsoft.com is outside the domain. So it can forward it to other DNS servers such as the ISP DNS server, so that name can be resolved. We also have something called conditional forwarding that was introduced by Microsoft in Windows Server 2003. Conditional forwarding forward requests based on the domain name. For example, let's say the name of our domain is contoso.com, and we have a multiple domain forest, for example. If somebody sends a request for adatum.com to a DNS server that's only hosting or authority for record for contoso.com, it can forward it to a certain DNS server because of the domain name adatum.com. We also have stop zones. Stop zone contains sensitive records, so you can identify the DNS server that's authority for a specific DNS domain. A stop zone, we have start of authority resource record, name server resource record, and the host A or the A resource record. It will also contain the IP address of one or more master server that you can use to update the stop zone. Stop zone can be created by using the new zone wizard. Another new feature is netmask ordering. Netmask ordering return address of host machines that are close in proximity based on the IP address of the client machine that does the DNS query. So it's going to return address of host machine that are close by to the IP address of the client machine that requests the DNS name query. Another new aspect we have in DNS is implementing DNS security. DNS is a very critical network service. You must protect it at all costs. A number of options have been available to protect DNS servers. Your DNS server, like I said before, is the blueprint of your organization, as all the name and IP addresses of all the machines on your network. So it's a it's a high target. It's a high target for malicious users and hackers. So hackers like to hack your DNS server. They can try to take you over. You can have to poison your DNS server. They would like to put bogus info in it so they can redirect traffic to a malicious website. So one of the ways to implement DNS security is DNS cache locking. DNS cache locking prevents entries in your DNS cache prevent entry from being overwritten until a certain time out of the time of leave has expired. So this is how this happens. If you know malicious user they like to write bogus information in your cache. We call that cache poison attack. For example, if the IP address 172.16.11.12 is supposed to be the IP address for a classified server, malicious users will put a bogus info or bogus IP address there. So when somebody query for that classified server, it sends them to malicious users server so they can hack your system. So what with DNS cache locking is going to make sure your cache is not overwritten until a certain time has passed. If your time to leave is an hour, you can say, well, until after 90% of the time has passed, nobody can overwrite that cache information. We also have the DNS socket pool. This is enabled by default in Windows Server 2012. This randomizes source port for issuing doing DNS query. You see, you have the range of ports that you use for DNS query. That way, hackers do not know the port you're using for DNS. That way, they cannot use that to hack your system. So on your firewall, you have a random set of source ports you're using for DNS queries. Last but not least, DNSSEC, DNS security. DNSSEC uses cryptographic signing of DNS record, so client machines can be sure or can validate DNS response. without DNS cache, without DNS cryptographic signing, without that, hackers can bring up their own DNS server and then try to compromise your network that way. But for every response from the DNS server is signed, so you know it's actually coming. It's digitally signed, so you know it's actually coming from a legit or legitimate DNS server. How does DNSSEC works? We're going to look at how DNSSEC work. It's when a zone has been digitally signed, so any query from that zone contains digital signatures, so you can actually verify that it actually came from that DNS server. Because if on the internet, this happens on the internet, can also happen on your local area network. Hackers can bring up rogue DNS server. If you try typing www.microsoft.com rather than give you the real IP address, it will give you the IP address of a bogus server. And if you connect to that server, they can hack your system that way. But if you're using DNSSEC, because the information is digitally signed, you can verify it's coming from a legitimate DNS server. They also use trust anchors, which are special zones that used to store public keys as associated with these digital signatures. DNS resolver also use trust anchor to retrieve public keys. All the DNS server participating using DNSSEC must have trust anchors configured. So that way you restrict what DNS servers can actually resolve name on the network. So there's some enhancement to DNSSEC in Windows Server 2012, includes simplified DNSSEC implementation, includes DNSSEC zone signing wizard. This zone signing wizard walks you through the process of signing and configuring sign perimeters for your zone. So it's easy to configure DNSSEC because DNSSEC zone signing wizard walks you through it. You also have new resource record in Windows Server 2012, such as DNS key, such as NSEC.